Show that f vector is equal to x square plus xy square I plus y square plus x square y j vector is irrotational. Find its scalar potential. So condition for irrotational is del cross f vector equal to 0. So this is the condition for irrotational. So I am going to find out del cross f. So del cross f vector is equal to determinant of I, j, k. Dou by dou x, dou by dou y, dou by dou z. And now the coefficient of I, x square plus xy square, coefficient of j, y square plus x square y, and coefficient of k 0 because there is no k terms. So now I am going to expand. So I vector into dou by dou y of 0 0 minus dou by dou z of this, but there is no z term, it is also 0, minus j vector into, leave this, dou by dou x of 0 0 minus dou by dou z of this, there is no z, this is also 0, plus k vector into, leave this, dou by dou x of this with respect to x is 0, here 2xy because x square differential 2x, minus dou by dou y of this, here 0 because there is no y, here y square is 2y, so 2xy. Therefore I vector into 0 minus j vector into 0 plus k vector into 2xy minus 2xy, with respect to y is 2xy. So 2xy minus 2xy 0. Therefore the entire value is 0. Therefore del cross f vector is equal to 0. Therefore f vector is an irrotational vector. So let the scalar potential of f vector be pi. Therefore f vector is equal to del phi. But what is f vector? It is given in the problem. It is x square plus x y square into I plus y square plus x square y into j, but there is no k coefficient, and del phi is I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Okay, equating the coefficient of I, j, k. So coefficient of x, I vector. So what is I vector coefficient? Dou phi by dou x. Here I vector coefficient is x square plus xy square. From this I want to find out pi value. So integrating with respect to x on both sides. So x is equal to integration of x square is x cube by 3. Here x integral is x square and y square term x square by 2 plus integral constant c1. You take it as equation number 1. Integration of dou pi by dou x is pi. Okay, next I am going to equating the coefficient of j. Coefficient of j vector. So what is the coefficient of j vector? Dou phi by dou y. So ij coefficient is y square plus x square y. To find phi value, integrating y on both sides. So when you are integrating with respect to y, this become pi. Y square integral y cube by 3 and x square y integral is y square by 2 plus integral constant c2. Take this is equation number 2. So no need to equate the k coefficient because there is no k coefficient. When you are equating this, the value becomes 0, so we can leave it. So from these two equations, I want to find out the value of scalar potential phi. So from 1 and 2, from 1 and 2, pi is equal to, so write the terms. If it is repeated, you write once. So x cube by 3 plus x square y square by 2 plus y cube by 3, and this term is repeated, so we can leave it. Now finally integral constant c. So this is our required scalar potential of the given vector point function.